Good afternoon. Thank you all for being so flexible yesterday. Had a meeting come up. Somebody came to visit our Excel Center and our plans went over and there was just no way I was gonna get there in time. So I appreciate you guys watching that video and doing your homework online. I have not had a chance to grade those. So give me today and I'll get them graded hopefully today before I leave. So before 4:30, I should have those graded for you. Today, we're going to look at solving equations containing rational expressions. So equations, we're going to have equal signs. Rational expressions just mean we're going to have a bunch of fractions. And we have these three steps in order to do that. The first step, we want to find the least common denominator. Then we're going to multiply every term on both sides of the equation by that least common denominator. Our objective in doing that is to cancel out all the denominators, which eliminates all of the fractions. Step 3, we want to just solve for the variable. So if we end up with a linear equation, we want to get the variable by itself. If we have a quadratic, we want to get everything on one side to get the equation equal to 0, and then we can go ahead and factor that. So we're going to look at our first example here. So our first example is a rational equation. In this case, we have one fraction on the left and one fraction on the right. This is the easiest example, or the easiest method in this case would be to cross multiply. So hopefully you've seen cross multiplication before, where you're going to multiply these diagonals together and you're going to multiply these diagonals together, set them equal to each other. So for the first diagonal, I'm going to take 6 and I'm going to multiply it by x plus 2. If I take 6 and I multiply it by x plus 2, it must get multiplied by both the x and the 2. So 6 times x is 6x, 6 times 2 is 12. For the other diagonal, we're going to have 7 times x minus 5. So then I'm going to take 7 times x, which is 7x, 7 times negative 5, which is negative 35. And now I have no more fractions. So my fractions are all gone. Now is where I'm going to decide whether I have a quadratic or a linear equation. So in this case, I have a linear equation because if you look at your variables, they're both x's. Neither one of them is x squared, which means it is linear. So to solve a linear equation, you want to get all your x's on one side, all your constants on the other. So I would subtract 6x from both sides. And that's going to give me 12 equals x minus 35. Then I'm going to go ahead and add 35 to both sides. So that's going to give us x equals 47 as our final answer. So that's the easiest possible scenario that could happen. This, however, is more than likely what you're going to see for this class. So in this case, we have more than one expression on one side. So if you look at the left side, there are 2 fractions. So we have 3 over k minus 1/2 equals 12 over k. So we're going to follow these 3 steps. We're going to find the common denominator. So to find our common denominator, we're going to look at all the denominators and compare them. So when I look at the denominators, I'm just going to look at these 3 things. So if I look at those, I see a K, I see a 2, and then I see another K. So my least common denominator would be 2K. So anything that's part of a denominator has to be listed as the least common denominator. But since K is in there 2 times, I don't have to write K squared. I can just write K. Then I'm going to go in and I'm going to multiply every single term by that least common denominator. So I'm going to multiply every single term in the numerator by 2K. So I'm going to multiply by 2K, multiply by 2K, and multiply by 2K. Now, if we've done this correctly, something in every fraction should be able to be canceled. So if I look at the first fraction, just looking at this one right here, I'm going to take 3 times 2K, which is 6K, but then I'm going to divide it by K. So here, the K's are going to cancel each other out. One's on the top of a fraction, one's on the bottom of a fraction. They're inverse operations. They're canceling each other out. So that's going to leave me with 2 times 3, which is just 6. The same thing's going to happen when I jump to this next fraction here. I'm going to take 1 times 2K, and then I'm going to divide it by 2. Well, multiplying by this 2 and dividing by this 2 are inverse operations. Multiplying by 2 and dividing by 2 cancel each other out. So now I just need to take the -1 times K, which is just -1K or minus K. A lot of times I'll have my students take this negative right here and move it up top to that 1, just so it doesn't get lost. Then I'm going to bring my equal sign down. And I'm going to look at the last fraction. I have 12 times 2K divided by K. Hopefully you've noticed the pattern here. The K in the denominator should cancel with the K that we were multiplying as part of the least common denominator. So now I'm just left with 12 times 2, which is 24. Now I'm looking at the equation I have left, and I need to decide whether it's quadratic or it's linear. So I'm going to focus on the variable. I only have one variable left, and it's just K. It's not K squared. So since it's just K, I need to solve for K because it's linear. It's not K squared, so it's not quadratic. So I would subtract 6 from both sides, cancel this out. So -K equals 18. Can't leave this as your answer because you have that negative. So you want to divide by -1 or multiply both sides by -1 to get K equals -18. And that's your final answer. So making things a little bit harder this time. Now, we have a quadratic in one of the denominators. So anytime that happens, we want to go ahead and solve or factor, I guess, the denominator that is a quadratic. So I'm going to take x squared minus 6x plus 8, and I'm going to factor it. Easiest way to factor that would be using the asterisk. So I would have 1 in the top left, top right, -6 in the bottom middle, and 8 times 1, which is 8, in the top middle. Then I'm looking for two numbers that multiply to give us 8, but add to give us -6. Hopefully you see that's -4 and -2. Those multiply to give us +8, but add to give us -6. So this no longer is here. We're going to replace it with the factored form. X minus 4, x minus 2. Order doesn't matter there as long as you have them both. And then, like I said, that's replacing the quadratic that was here. Factored it. Because now we're going to go through and look at our common denominator. So when I look for my common denominator, first thing I notice is these two match. And I also notice that these two match. 9 times out of 10, it will happen this way. At least one of them will match, would be my guess. So when I make my least common denominator, I need x minus 4 in it, but I also need x minus 2. So your least common denominator is going to be x minus 4 times x minus 2. That means when I go through and I multiply every term by that common denominator, I'm going to multiply by those two sets of parentheses 3 times. Just like this. So now before I go ahead and do that multiplication here, I know that for the first fraction, when I look at it, the x minus 4 should cancel with the x minus 4. I'm multiplying by x minus 4, but I'm also dividing by x minus 4, so those will cancel. That's going to leave us with just this 1 times the x minus 2. Well, the 1's going to get multiplied by the x to get 1x. The 1's going to get multiplied by the minus 2 to still get minus 2. That takes care of the first fraction, and then we're going to repeat this process on the second fraction. For the second fraction, the x minus 2 is going to cancel with the x minus 2, and that's going to leave us with x times x minus 4. Well, that x is going to get multiplied by x to get x squared. The x is going to get multiplied by the minus 4 to get minus 4x. Bring your equal sign down. For the last fraction, the x minus 4 is going to cancel with the x minus 4. And the x minus 2 is going to cancel with the x minus 2. That leaves us with just the 2 in the numerator. So now we've eliminated all the fractions all the way across. So we're going to look at, do we have a quadratic or a linear equation left? So when I start to look at this, the x squared right here stands out to me. X squared indicates that we have a quadratic. So I know I have a quadratic, which means I want to move everything to one side. So in this case, I would move the 2 to one side, but before I do that, I want to write this in standard form. Standard form always starts with the x squared first. Then I would combine these two terms here, the x and the negative 4x to get negative 3x. And then the minus 2 equals 2. So just simplifying things before I start getting this into form to factor. So now I'm going to subtract 2 from both sides to cancel this 2 out. Because remember, we have a quadratic, we want to get 0 on one side so we can factor. So x squared minus 3x minus 4 equals 0. Off to the side somewhere, you're going to take that quadratic and you're going to factor it. So you're going to have 1 in the top left, 1 in the top right, negative 3 in the bottom middle. You're going to take negative 4 times 1, which is negative 4 for the top middle. So now two numbers will multiply to give us negative 4 and add to give us negative 3, going to be negative 4 and positive 1. So then I'm going to look at the two sides, neither side reduces. So I'm going to have factors x minus 4 and x plus 1. Well, the zero product property tells us that if we have two factors being multiplied together and their product is 0, then one or both of them must equal 0. So we're going to set x minus 4 equal to 0 and x plus 1 equal to 0. Going to solve both of these for x. We're going to get x equals positive 4, x equals negative 1. This is also the first time we've ever ended up with two solutions. Anytime you end up with two solutions, you need to check them. When we check them, we need to just look at the denominators and make sure if I plug a value in, it's not going to give me an undefined denominator. Remember, we're not allowed to divide by 0. So I just want to check to make sure that if I plug x equals 4 into all the denominators, I'm not going to get 0. So very quickly, when we start to do that, if I plug 4 into this denominator for x, I'm going to have 4 minus 4, which does in fact give me 0. That tells me that x equals 4 is extraneous. It's not part of your answer. It can't be part of your answer because if x equals 4, that first fraction you would divide by 0, and you're not allowed to do that. So then we can check negative 1. Again, if I started that first fraction and plug in negative 1 for x, I would have negative 1 minus 4. Negative 1 minus 4 is negative 5, so that's good. It's not 0. Then I would go to the second fraction, plug in negative 1 minus 2, we know is negative 3, so that also would not give me 0. And then we know that that last fraction over here, this one, this factors into x minus 4, x minus 2. We actually just checked both of those factors, so we know that negative 1 is going to work. It's not going to make that denominator 0. So x equals negative 1 is your final answer. All right, for the next problem, the first thing I want you to try to do, so see if you can, without my help, find the common denominator. So it's going to be very similar to the last question. So for our first step, we want to take the quadratic that's in the denominator over here, and we want to factor to find the two factors. So again, likely you would put that into your asterisk to find two numbers that multiply to give you -6, but add to give you +5. So 6 and -1 are your two numbers. These two factors are not going to reduce. So we're going to use factors x plus 6 and x minus 1. Or m, I guess, in this case. So m plus 6, m minus 1. And again, we can get rid of this denominator here because we replaced it with its factored form. Now that we have that factored, we can go ahead and look into the common denominator. So for the common denominator, I have an m plus 6. Again, that's found here and here. But then I also have an m minus 1 that can be found here and here. And then that takes care of everything that we have in the denominator. So that would be our least common denominator. Then I'm going to go through and I'm going to multiply every single term by our least common denominator. So m plus 6 times m minus 1. So now we're going to go through and we're going to multiply every single term and cancel while we can. So looking at the first term, the m minus 6 in the numerator and the denominator will cancel. The 4 that's left up top here is going to get multiplied by the factor m minus 1. So we're going to take 4 times m to get 4m. And we're going to take 4 times the minus 1 to get minus 4. And that's going to take care of the first fraction. Then we're going to do the process on the second fraction. Looking at the second fraction here, we are going to be able to cancel the m minus 1 in the denominator with the m minus 1 in the numerator. That's going to leave us with 1 times m plus 6. So I'm going to multiply 1 times m to get m. It's positive, so I'm going to put a plus sign. Then I'm going to take 1 times 6 to get 6. And that's going to take care of the second fraction. Looking at the last fraction over here after the equal sign, we can cancel the m plus 6 in the numerator with the m plus 6 in the denominator. We can go ahead and cancel the m minus 1 in the numerator with the m minus 1 in the denominator. For this term, there is no multiplication left. We just have the 3m plus 6 that was in the numerator left. So now I'm going to look at what's left, and I'm going to decide whether this is a quadratic or a linear equation. Again, we're always looking at the variables to see if we have any x squareds, or in this case, m squareds. For this problem, we do not. So this is just a linear equation. We want to get our like terms put together, and then we're going to move all the variables to one side, all the constants to the other. So in this case, I'm going to combine the 4m and the m. They're on the same side of our equal sign here. So here's my equal sign. Since those m's are on the same side of my equal sign, I'm just going to add them as they're written. 4m plus m is 5m. Same thing's true about the -4 and the +6. They're both on the left-hand side of the equal sign, so I'm going to combine them the way that they're written. -4 plus 6 is +2. So just a step of simplification. And now I want to go ahead and start moving things across the equal sign using addition and subtraction, right? So I'm going to move the 3m first to cancel it out on the right-hand side. If I subtract it from the left-hand side, it's going to give me 2m plus 2 equals 6. At this point, I'm going to subtract 2 from both sides to get 2m equals 4. And at this point, we have 2m equals 4, the 2 sitting beside the m, so we're going to divide it by 2. To eliminate it, if we divide one side by 2, we've got to divide the other side by 2, and that's going to give me an answer of m equals 2. In this case, we only ended up with one solution, so there's no real reason for us to have to check this. Wouldn't take us that long if we did check it. We would plug 2 into both the denominators or the least common denominator. M plus 6, if I take 2 plus 6, it's going to give me 8. If I take 2 minus 1 for the other denominator, it would give me 1, which also works just as well. So remember, when you check those, you're just looking for zeros in the denominator. All right, we've got one more. First thing we're going to do is find the common denominator. In order to find the common denominator, I'm going to need you to factor the quadratic that is in the current denominator. So take a moment and factor the b squared plus 6b plus 5 to find the two factors. All right, so hopefully when you factored the quadratic in the denominator, you ended up with b plus 5 times b plus 1 as your two factors. In this case, when you go to find your common denominator, the first thing I notice is the b plus 1. So I'm going to put b plus 1. That b plus 1 in this case is here, here, and here. It's in actually all three denominators. And then when I look at what's left, I just have the b plus 5 left. So it also has to get written up here, b plus 5. And then that takes care of all the terms in the denominator. So I'm going to multiply every single fraction by b plus 1 times b plus 5. Just like that there. So now when we go to do our multiplication for the first fraction here, the b minus 1 is going to cancel with the b minus 1. We're multiplying by it, and then we're going to divide by it. So those are going to cancel each other out. However, in the numerator here, we cannot cancel the b plus 5 with the b plus 5. They're both in the numerator. So we're not allowed to cancel those out. We are going to actually have to multiply them together. So hopefully we know by now that when I have to multiply b plus 5 times b plus 5, that actually creates, again, a box problem like we talked about the other day. So we'll box that in just a minute. We're going to go ahead and keep simplifying here to eliminate all of our fractions. So for the second term, right after our equal sign, the b plus 1 is going to cancel with the b plus 1. The b plus 5 is going to cancel with the factor b plus 5. And that's just going to leave us with 2. And then the last term we have here, we're going to be able to cancel the b plus 1 with the b plus 1 in the denominator. And that's going to leave us with 1 times b plus 5. Well, if I take 1 times b, I get b. If I take 1 times 5, I get 5. So now on the left-hand side, we're going to go ahead and box the b plus 5 times the b plus 5. I'm going to go over here to the side. B plus 5 times b plus 5. Again, if you were taught to FOIL or double distribute, you can multiply those together that way as well. So here I'm going to have b times b, which is b squared, b times 5, which is 5b, b times 5, which is 5b again, and 5 times 5, which is 25. So when I go through and combine like terms here, I'm going to have b squared plus 10b plus 25. And then on the right-hand side, I'm going to go ahead and combine the 5 and the 2 to give me b plus 7. Now that I've done all that, I'm going to go ahead and look at the equation I have left, and I'm going to decide whether it is linear or quadratic. Since the first term over here on the left-hand side has a squared, an exponent of 2, I know this has to be quadratic. Since this is quadratic, I want to move everything to one side so that I can factor. So I'm going to subtract b from both sides. Again, here's my separation of my two sides. I'm also going to subtract 7 from both sides. Sometimes we do this in 2 steps, but we're going to save ourselves some time by doing it all at once. So that's going to cancel both terms on the right-hand side and give us 0. On the left-hand side, we're going to have b squared plus, I have 10b minus 1b. 10 minus 1 gives us 9b. And then 25 minus 7 gives us positive 18. So now we have b squared plus 9b plus 18, a quadratic that we need to factor. In order to factor it, we're going to jump over to another asterisk. So we're going to have 1 in the top left, top right, 9 in the bottom middle, and 18 times 1 in the top middle, which is 18. So we're going to find two numbers that multiply to give us 18, but add to give us positive 9. So those two numbers should be 6 and 3, 3 and 6, order doesn't matter. And they're both positive this time. So now I'm going to have factors b plus 6 and b plus 3. Then we're going to take these two factors and we're going to set them both equal to 0. So b minus 6 equals 0. B plus 6, excuse me. B plus 3 equals 0. And then we're going to solve them both for b. So b is going to equal negative 6. B is going to equal negative 3. Now, like I said last time, because we got two solutions here, we need to go back and make sure that if we plug either one of those into our least common denominator, that nothing's going to equal 0. Or we can just look at the individual terms down at the bottom. So the b plus 1, if I plug in -6, it would be -6 plus 1. That's going to give us -5. That's okay. As long as it's not 0, it's okay. Same thing's true as if we plug it in, over here. -6 plus 5 is going to give us -1. That's also okay. And then we know the rest of the problem just repeats the b plus 1. We've already checked it once. So we know that -6 is a solution. Then we're going to go back and repeat the process with -3, because again, we got two answers. We need to check them both. So if I plug in -3 here, -3 plus 1 will give me -2. That's going to work as long as it's not 0. We're not allowed to divide by 0. And then if I plug in -3 plus 5 is going to give us +2. +2 is also not 0, so it will work as well. So I can go back and circle my answer. This time we have 2 answers for our solutions. So sometimes we'll get 1, sometimes we'll get 2, and one of them will be extraneous, which we had happen earlier. And then sometimes you'll factor and you'll get 2 solutions and they will both be correct.